So normally low Z mode is used to detect ghost voltage. I have been unable to create what I consider ghost voltage in my lab.
I'm your huckleberry.
Well, ghost voltage is usually considered like an induced voltage from one circuit to another, or one circuit to a stationary piece of metal or something like that.
All right, let's get into this. And I'm not trying to call Steven out or saying he's wrong or anything like that. He actually asked some questions in the group chat about ghost voltage. So hopefully this video will kind of clarify some stuff in low Z mode and everything. But anyway, you see my meter's reading 155.8 volts. It's DC, but I am feeding it just with 120 volts AC through a bridge rectifier to get the DC. But how am I able to get such a high voltage reading? Well, on the DC side of the bridge rectifier, I have a whole crap ton of extension cords, and I tried to uncoil it just because people were always like, oh yeah, it's because it's coiled. It's not because it's coiled, but regardless, I did uncoil it. Off the bridge rectifier on the DC side, I've got that super long extension cord. It runs over to this keyless light fixture, and I ran some pigtails off so I could put my alligator clips on. But it's keyless light fixture, 60 watt incandescent light bulb. So if I screw the light bulb in, you can see my voltage drops. When your meter's in its normal state and you're taking voltage readings, its impedance is really high. When we use our probes, or in my case, my alligator clips, we don't want to alter the voltage or anything like that. We just want to see it. So we want that high impedance so we're not changing anything. When you put it into low Z mode, you're basically doing the same thing as the light bulb. You're actually applying a load for that voltage to bleed off. We were reading 156 volts DC. In low Z mode is 107.8. So where's this 48.2 volts? Let's calculate how much energy we stored in that super long extension cord that was acting like a capacitor. By the way, your meter can read capacitance. I bet a lot of people didn't know that. But anyway, I came up with 1.74 nanofarads, and it comes out to 0.000021 joules. To put that into perspective, to run that 60 watt light bulb, we need about 60 joules a second. We only had 21 millionth
Today, Junior?
of a joule. Is this voltage reading real? Absolutely. We were reading 156 volts with low Z mode or a load applied. It dropped down to 107.8. So where did that 48.2 volts go? Well, it goes to the load, but because we don't have anything to back it up, it essentially vanishes in 0.42 microseconds. Because the only thing that was sustaining it is that tiny bit of stored energy from the long extension cord acting like a capacitor. Why don't we always just run the meter in low Z mode? Well, remember, when we're taking voltage readings, we don't want to impede the circuit at all. We want that high impedance so we can see what the voltage is. When you're in low Z mode, it essentially applies a load to the circuit and bleeds off that extra voltage, but it also can cause other problems. You want to use that low Z mode if you suspect you have ghost voltage. By the way, in my case, the proper term would have been capacitive coupled voltage.